Today we're going to talk about solving polynomial inequalities. And the method that I'm going to show you depends on graphing the function that's associated with the inequality and then interpreting the graph as to whether the points are above or below the x-axis. For each one of these, we'll either have a graph to start with or we'll sketch a graph of the function to be able to solve the inequality. Let's start with this function, and all we have for this function is a graph. We don't have the actual function formula. When we go to solve these two inequalities, we're going to have to figure out what that means in terms of the graph. Remember when we talked about functions that the function values are the same as the y values of the points. So if we had a point on the graph, say right here, this would be the point xy or the point x f of x. We could think of it either way. If we want to solve the inequality f of x is greater than 0, what we want to know is where the y values of our points are greater than 0, or in other words, where they're positive. So we want to find the points where the y values are positive. And another way to say that is that we want to look for all the points that are above the x-axis. If their y values are positive, then those points have to be above the x-axis. Now, an easy way to do this is to go through first and find where the x-intercepts are. The x-intercepts are points where the function value is actually equal to 0. On either side of an x-intercept, you'll have a whole range or a whole interval where either all of the points are above the x-axis or all the points are below the x-axis. In this graph, we've got two x-intercepts. This one is the point 0, 0. This one is the point 3, 0. And remember, when we're solving this inequality, we want to solve it for x. We want to come up with some answers that are intervals along the x-axis. And once we've found our x-intercepts, what we're going to do is use that to divide our graph up into sections. I'm going to draw a dotted line, vertical line, that goes through each of our two x-intercepts. So here's one at x equals 0. Here's another one at x equals 3. Now I have my graph split up into 3 sections. I'm going to go ahead and write the interval that would describe each one of these sections. For this interval, this is going from negative infinity all the way to 0. So for this one, the interval would be negative infinity to 0. For this one, this is going from 0 to 3 on the x-axis. That means our interval would be 0 to 3. And on this one, we're going from 3 on the x-axis all the way up to infinity. There are 3 intervals that describe the 3 sections of our graph that are between the x-intercepts. Now what we want to do is look for points that are above the x-axis. In each one of these intervals, we're just going to write down whether the points are above or below the x-axis. In this interval, you can see that all the points are above the x-axis. I'm just going to write above down here. In this interval also, the points are above the x-axis. And in this interval, the points are all below the x-axis. So when we went through this x-intercept, it actually didn't change from one side to the other where our points were. But when we went from this interval to this one, when we crossed through that x-intercept, we went from having points above the x-axis to having points below the x-axis. Now we can go back, since we've got this part done, and just pick out which one of these intervals are solutions for our problem. What we were looking for, since we wanted our function values to be greater than 0, is points that were above the x-axis. The 2 intervals that fit that are this one and this one. So our solution for this would be the union of these 2 intervals. All we have to do is write the 2 intervals and put the union symbol in between. And that's the solution for our inequality. Now let's look at another one with this graph. This time we want to solve the inequality f of x is less than or equal to 0. Again, we need to interpret what this inequality is telling us. Less than 0 would mean that our y values are negative. And if we're thinking about where that would put our points, if we have a negative y value, that means our point is below the x-axis. The other thing with this one is we also have an equal sign. If we have a function value that's equal to 0, that means the y is 0, which puts the point on the x-axis. Well, these points that satisfy this are going to be our x-intercepts. So what this is really saying is we're looking for points that are either below or on the x-axis. If we take what we already did for the last part of the problem, we can see that the ones that satisfy this part are between 3 and infinity. So for this part it's 3 to infinity, but then we also want to include any of our x-intercepts. So we do want to include the 3. We could do that just by changing this from a parentheses to a bracket. But we do have one other x-intercept, and that is that x equals 0. Now this has to be part of our solution also. One way that you can write this as an interval if you really want to is just make it a closed interval from 0 to 0. This means that 0 is the endpoint on both ends, so it's really just that x equals 0. This would be our solution for this inequality.